Step 3. Creating the 2D script. We'll now start creating the 2D script for the table. Insert the following lines into the 2D script. We already know the pen command. The fill command sets the fill type to be used in subsequent commands where it applies. As you can see, we used the gs_cont_pen and gs_fill_type default parameters defined in the table subtype to make the object as standard as possible. Open the GDL Reference Guide by clicking on the Help ArchiCAD GDL Reference Guide menu item. Find the description of poly2_b command on page 120 of the reference guide. Select the command syntax and copy it to the clipboard. Paste the command syntax at the end of the 2D script. The poly2_b command creates a filled polygon. Both the individual edges of the polygon and its fill can be set to be displayed or hidden. The poly2_b command shows some similarity to the prism_ command, especially in the triplets defining the coordinates and their status. The n parameter specifies the number of points of the polygon. The frame_fill parameter is used to define how the fill is drawn. The fill_pen parameter defines the pen used to draw the fill's pattern. The fill_background_pen defines the pen used to draw the fill's background color. The x1, y1, s1, etc. triplets define the x and y coordinates of the individual points of the filled polygon and their status. Go to the floor plan and activate the 8.4 2D script variables saved view from the navigator. We are going to use the same parameter and variables for the 2D of the table that we were using for its 3D. We will need to create two cases in 2D as well. One for the case when there is no insert piece in the middle, and one for the case when there is. We will achieve this with an if-then structure. First, let us just create the case when there is an insert piece. Go back to the Library Part Editor window, activate the 2D script, and modify the poly2_b command syntax to the following. The fill created by this poly2_b command has 8 points. The 7 plus 64, 1 plus 2 plus 4 plus 64 value for the frame_fill parameter means that we want the contour to be shown, 1. We want the fill pattern to be shown as well, 2. We want the polygon to be closed, 4. And we want our fill to be a cover fill, 64. The fill's pattern will be drawn with the pen defined by the gs_fill_pen default parameter, and the fill's background with the gs_back_pen default parameter. Notice that we again used default parameters defined in the table subtype. We will now create the if-then structure. Place the following lines before and after the poly2_b command so you get the following result. We'll evaluate the value of show_insert parameter just like in the 3D script. However, there is a new element in the structure. It is the else keyword. The structure is the following. If, condition then, command if true, else, command if false, end if. The else keyword lets you define what you want the program to do in case the condition is not met. The normal if-then structure is used if you want to perform certain command if a condition is met. The else variation is used when you want to perform either one of two sets of commands depending on the value of the condition. In our case, we want to generate a different geometry in case there is an insert piece, show_insert equals 1, and another when there is no insert piece. Insert the following code segment between the else and end if lines. The only difference between this and the other poly2_b command is that the x-coordinates are not shifted by the insert_length_per2 value in the appropriate places. Select each of the poly2_b commands and all the code lines belonging to them and indent them one tab position. With this, the code is more readable. Also, it can be clearly seen that this command belongs within the if-then command structure. Activate the 2D full view window and check the 2D of the table. Switch the show_insert parameter on and off to see how the 2D changes based on its value. When you're finished, switch the parameter back on. We will now place hotspots on the 2D of the table. Find the code syntax for the hotspot2 command on page 117 of the GDL reference guide. As you can see, all the parameters except the first two are in parentheses, meaning they are optional, so we will not deal with those. In its simplest form, the hotspot2 command is used to generate a hotspot into the 2D of the object. If there are no hotspots generated for an object in its script, there are 5 default hotspots generated by ArchiCAD at the 4 corners of the enclosing rectangle of the object's geometry and at the center of that enclosing rectangle. If there are hotspots defined, then the program does not have to create them. We will place hotspots at several special points of the table's 2D so we can select by these positions or later snap the object by these positions. Go back to the 2D script of the object and place the following lines of code above the line containing the else keyword. Check the 2D full view window for the result. We have placed hotspots at the centers of the curves and at the quarter points of the curves, 8 hotspots in all. This gives us hotspots in case there is an insert piece. Now we need to make the same hotspots in case there is not an insert piece. Insert the following lines of code before the endIf command in the 2D script. Switch off the show_insert parameter and check the 2D full view window for the result. Just as in the case of the master script, there are certain hotspots we want to define that are located at the same place regardless of the value of the show_insert parameter. These we place after the whole if-then structure to always be executed. Insert the following lines of code after the endIf command in the 2D script. With this, we create 3 additional hotspots at the middle, the top middle, and the bottom middle of the table. Activate the 2D full view window to see the result. With this step, we are finished with the geometry. Save the completed object.